Today we will learn the kinematical equations to solve one-dimensional motion. Firstly, when a particle is in uniform velocity v, we have to find out the displacement or the distance traversed by the particle in time t. Here v is uniform, that means velocity will not change with respect to time. If we say that a car is moving with uniform velocity 20 km per hour, that means in 1 hour the car moves 20 km. Here v is the uniform velocity, that means in unit time the particle moves v unit. In time t, the particle moves vt. So the distance, if we denote by s, then s is equal to vt. When a particle moves in uniform velocity v, that means velocity will not change with respect to time, then after a particular time the product of velocity and time is equal to the displacement or the distance traversed by the particle. This is the first equation. Second equation, a particle moves but only starts with velocity u. After time t, the velocity is increased as well as because the particle is in acceleration a. So what is the velocity of the particle after time t? Again, u is the initial velocity of the particle and the particle has acceleration a. What is the velocity of the particle after time t? Let us consider that the velocity of the particle after time t is v. So the increase of velocity v minus u in time t, the increase of velocity is v minus u in time 1 in unit time. That means in unit time the increase of velocity is v minus u by t. Actually, from the definition of acceleration in unit time, the increase of velocity is called acceleration. So acceleration a is equal to v minus u divided by t. That means V minus U is equal to AT and V is equal to U plus AT. This is the final velocity of the particle after time t. If there is retardation, then A is replaced by minus A. If there is retardation, that means the velocity decreases with respect to time. Then A is replaced by minus A and then V is equal to U minus AT. That means after time t, the velocity V is U minus AT. This is the second equation. Now, the third equation we consider, that means here after a particle starts with uniform velocity U and there is acceleration A, what is the distance traversed by the particle in time t? We have to find out S. What is S in a time t? This particle, again we say, the particle starts with uniform velocity V, U, and there is acceleration A. That means velocity increases with respect to time. What is the distance traversed by the particle in time t? Here we consider that the distance is S and after time t, the velocity is V. That means the terminal velocity when the particle covers the distance S, then the terminal velocity or the final velocity is V. Here the velocity gradually increases with respect to time. So if we have to find out the distance, then we have to consider the average velocity. U is the initial velocity, V is the final velocity. So the average velocity U plus V by 2. This is the average velocity. Now we consider the particle is not in acceleration. The particle is in average velocity. That means the particle goes with respect to time is in average velocity U plus V by 2. Hence there is no acceleration. So the distance is when the particle moves with uniform velocity, that means this is the average velocity, then S is equal to Vt. Here we consider V is equal to U plus V by 2. So S is equal to U plus V by 2 into T. So U plus V is equal to U plus AT. We know by 2 into T. By simplification, 2U plus AT into T by 2. That means 2UT plus AT square by 2. 2UT by 2 plus half AT square. That means S is equal to UT plus half AT square. If there is retardation, then as before A is replaced by minus A and then S is equal to UT minus half AT square. Here this is the third formula. Today we learn the three formulas: S is equal to Vt, V is equal to U plus AT and S is equal to UT plus half AT square.